Students, welcome to s.mathguru classes. So our main discussion is Charpit's equation or partial differential equation. We solve some problems by using Charpit's method. We can easily solve some problems by using Charpit's method. Now let us consider one problem. Solve by using Charpit's method, p²+q² equal to qz. This is our problem. Now solution, this is f of x, y, z, pq equal to 0 is p² + q² into y minus qz equal to 0. That means this whole we consider f. This is in the form x, y, z, pq. This. So x not given, but here we have in the form of this. We consider this whole is f. Now before solving Charpit's equation, first we have to find partial differentiation. So this can be written as, that is f equal to, we get p²y q² minus qz, this equal to 0. Del f del x, this is del x p² q² qz. This is 0, 0, 0 because we differentiate partially with respect to x. X is absent here, so all of this constant 0. Del f del y. This is del f del y. This is p² q² minus qz. This one p² into 1 q² into 1 minus 0. This is p² plus q². Now del f del z, del f del z. So this is del z p² plus q² minus qz. This is 0, 0 minus q into 1. This is minus q. We get del f del z is minus q. Next we consider del f del p. Del f del p. This is del p p² q² minus qz. This is p means twice py plus 0 minus 0. This is twice py. We get this. And del f del q. This will be del q p² plus q² minus qz. This is 0 twice qy minus z. We get, this is the del f del q, 2qy minus z. We get these are the values of del f del x, del f del y, del f del z, del f del p, del f del q. So according to Charpit's, the Charpit's equations are, the Charpit's equations are this dx by minus del f del p, dy by minus del f del q, dz by minus p del f del p minus q del f del q, minus p del f del p minus q del f del q, and dp by del f del x plus p del f del z, dq by del f del y q del f del z, this one, and this equal to d phi by 0. We get this is our Charpit's equation. You have to by heart this equation, otherwise not possible to solve. So this is dx by del f del p, this is minus given, first we write minus del f del p, this is 2py, dy del f del q, this is twice qy minus z, twice qy minus z, dz by minus p del f del p, del f del p, this is 2py, 2, this is 2py minus q del f del q, this is twice qy minus z, and dp by del f del x, del f del x is 0 plus p del f del z, this is minus q dq del f del y, this is p square plus q square, q into del f del z, del f del z is minus q, and this is d phi by 0. So this implies dx by minus 2py dy by minus 2qy plus z dz by minus 2p square y minus 2 q square y plus qz, and dp by minus pq dq by p square plus q square minus q square d phi by 0. We get this. This implies dx by minus 2py dy by minus 2qy plus z dz by minus 2p square y minus 2q square y plus qz, this equal to dp by minus pq dq by p square, because q square cancel, and d phi by 0. These are, after putting the values and simple calculate, we get this one Charpit's equation. Now in these equations we choose a simplest integral in p and q. This is if we consider this and this, we can easily solve this. Now simplest form is this. Now dp by minus pq dq by p square, this implies 1p is cancel, dp by minus p dq by p, dq, this p is cancelled, this is q, and cross multiplication p dp minus q dq. Taking this on left hand side, p dp plus q dq equal to 0, and this will be p square by 2 q square by 2 equal to, we consider a square by 2. Constant c actually we consider a square by 2. 2 cancel, we get p square plus q square equal to a square. We get p square plus q square equal to a square we get. Now putting this value in equation number this, since p square plus q square into y equal to qz, and by our consideration p square plus q square means a square, we putting this value here, a square y equal to qz. So this implies q equal to a square y by z, q equal to a square y by z. And since q square, this is p square equal to a square minus q square, because p square plus q square equal to a square. So this implies p square equal to a square, and q means this a square y by z, this whole square. This is p square a square a to the power 4 y square z square. This p square equal to a square common, 1 minus a square y square by z square, and this is p square equal to LCM is z square minus a square y square, we get this, and p equal to a by z root over z square minus a square y square, we get this. Therefore p is this, q is this. Since dz equal to p dx plus q dy, and putting the values dz p just we get az by a by z root over z square minus a square y square dx. q means a square y by z dy, we get this. So we get this one, multiplying both sides by z, then z dz, this is a root over z square minus a square y square dx a square y dy, we get this one. Now we taking this one in left hand side, z dz minus a square y dy, this is a root over z square minus a square y square dx, and this implies z dz minus a square y dz by root over z square minus a square y square, and this is a dx, we get this. So we integrate both sides. So if we integrate both sides, we get this one. But if we differentiate z square, we get 2z. Differentiate y square and 2y, but 2 absent, we write here in this way. This is 2z dz minus a square 2y dy by root over z square minus a square y square, this, and this is 2 extra, we write 1 by 2 is outside, this equal to a into dx. So this is the standard integration. We know this formula, integration f dash x by root over fx dx, this is 2 times of root over fx plus c if derivative differentiation of under root given in numerator, then answer 2 times of denominator. So this differentiation given here, we get 2 times of denominator, 1 by 2 into 2 root over z square minus a square y square. This is ax constant, we consider b constant. Next 2 cancel, z square minus a square y square. This is ax plus b. If we squaring both sides, then this root over will be cancelled, and this is ax plus b whole square. We get this one, and this is the final answer. So very easy solution, but most important for exam. Thank you.